Okay, this is a continuation of section 2.5 for MAC 1105. We had just gotten finished up talking about horizontal stretching and shrinking, and we had finished this problem using our parent points, noting that this was something that would be done on the x coordinates since the operation is inside with the x. But those operations on your x coordinates always get reversed. So if they're asking you to divide by 2, which is what it means to multiply by 1/2, it means x divided by 2. Opposite operation was to multiply by 2. That's how we got all of these x coordinates. We just multiplied all of them by 2 while leaving the y coordinates as is. We did not change them. So that was a 4, that was a 0, that was a 4. Then we graphed them, our original points, giving them a parabolic shape, that's f of x, and then our transformed points, giving them also a parabolic shape. And you can see that this has stretched out horizontally. Okay, moving to the last page where we start to wrap this up and talk about what happens when there are several transformations all in the same problem. There has to be a specific order in which we perform transformation doesn't come out properly. So here's an example of a parent graph in the cubic shape. And then there are several transformations here. There's a horizontal shift of +1. Remember those horizontal operations, always you perform the opposite operation. So if it says to subtract 1, we're really going to be adding 1. And horizontal means you'll be performing it on your x's. Then there's 2 more operations. Notice that this 2, it's a multiplier, and because it's not inside here with the x, it is something that we're going to perform on the y coordinates. So we have an operation where we're going to multiply, and we have an operation where we're going to add. This is also going to be performed on the y, because again, if this was something that you were being directed to do to x, it would be inside here with the x, and we already have something in there that's a number that we're going to, it presents as a subtraction sign, but we're really going to be adding. So these are both operations that are going to be performed on the y's. And there's an order. It's almost like order of operations when you're just trying to evaluate an expression that has several things to do in it. We always multiply before we add, and that's going to be the same thing here. We are going to take our y coordinates and we're going to multiply them by 2. Then we're going to do the addition of 3, so that we're performing this transformation first, and then last we're performing the vertical shifting. Okay, so we have vertical shifting going on here. We have vertical stretching going on in this problem, and we also have horizontal shifting going on. There is no reflecting. That's when you multiply by the -1s, and there's none of that going on. So we're not flipping over the y-axis nor the x-axis, but we are doing these 3 things and in a specific order. We're going to do our horizontal shift first. Then we're going to do our vertical stretching, and then we're going to do our vertical shifting. Okay, in that order. So using the points that I've given, again, I just selected these arbitrary, easy to work with, and I purposely plugged them into the easier function, which is always the parent graph. So I plugged in -1 here. -1 cubed is 1. I plugged in 0 for x, and I got 0 for an answer. I plugged in +1 and got 1 for an answer. And based off of these 3 points, but without going into all the complications that you may encounter if you just directly plug in your new x values into this. That's going to be a lot harder than just doing simple addition, multiplication, and then addition again. That makes it a lot easier. You're not even getting involved in any of these powers or anything by doing it the way that we've been doing it throughout this entire section. So let's see. The only thing that we're actually doing to the x's is we're going to perform a horizontal shift of +1. We're following this plan right here. We're taking all the x's and adding 1. So let's get our points ready. We're working off these parent points and we are adding 1. So -1 plus 1, 0. Adding 1 on the x's. 0 plus 1, 1. And then 1 plus 1, 2. Okay, then we're doing a couple of things to the y values. We're taking the y values and we're multiplying by 2 as well as adding 3. Okay, so let's do that. And I'll write that right down here, that we are taking the y values from the parent point, multiplying by 2, and adding 3. And you may be able to do that in your head, which is fine. But if not, you can always write it out. I'll just write it out for this first one. So we took that first parent y coordinate and we went 2 times 1 is 2, added 3, we get 5. We're going to do the same thing here. We're going to take that parent y coordinate and go 2 times 0 plus 3, that gives us 3. Again, we're going to take that parent y coordinate, and again, you should be very much probably able to do that without writing it out, but that's up to you. So you see that we got this to write it out at all. That's even less reason why you should need to write it out. So we got these transformed points. We know that we are going to be connecting these points whether you're on the parent graph or the transform graph in a cubic shape. Okay, so 1, 1, that's like that. We have a 0, 0, and we also have a 1, 1. There is a mistake here. Yes. There is, when you plug in a -1 here, you get -1. There's an error there. Please correct that on your worksheet. And then when we go to do this one,